Hi everybody, welcome to this third episode on the Module17 Revision 1. I hope you're doing alright. Today we will keep doing the components layouts and start routing them on the board. Hi Jay, I think you're first. Yes. Let's put the music on before we forget. Okay, I think, is the music loud enough or not too loud? Just tell me. So let's immediately go to the PCB editor. Okay, so that's where we left yesterday. Hi, Juan. Greetings from Argentina. Well, thank you. Greetings to you. I think it's the first time I see you around. So yeah, yesterday we left the board in this state and we had to decide on where we would put the power supply, basically, which, yeah, it might be a bit tight to squeeze everything on the board, so we'll have to route carefully. Hi, Paolo, from Italy, I guess, 73s. Okay, so what would be a good way to start this? I would be tempted to try first, maybe we should start routing the audio subsystem, or maybe we should focus on trying to find an 8P8C connector that we can use. That would be a good idea so that we can get rid of this square on the board. So let's look for 8P8C connectors. In stock. We want them in stock, and yeah, regarding the prices, that's not the most important, but we want something without an LED because we don't need one. Looks like we don't have a lot of choice without LED here. So looking from the LCSC website, which is the one which works with JLC PCB, so that we can ensure that this is easier to manufacture them from JLC PCB's website. Okay, basically we have 3 of them. It looks like they are all nearly identical. So I don't know what's the difference between those. Maybe there is a data sheet which you can have a look at. Oh, yeah, maybe not. Okay, can we spot a difference? Yeah, the height of the oh, it looks like this one is in reverse or something like that. Does OHIS specify anything about this? Okay. So about microphones, levels, electrical levels. I don't think yet. There is nothing about that. Okay, well. I do believe that this form factor is the most frequent, and I don't think there is anything major. There is no major difference between those two, I think. Can we spot a difference in the footprint or not? Yeah, they are not exactly the same. This one is... Yeah, okay, they are not the same. Definitely not. Okay, it's between the -59 and -58, and yeah, have no idea if there is any difference. Okay, so let's pick the cheapest one, which is this one. Okay, so it's gonna be this one, -58, so it's this. Okay, then I guess we will need to create the footprint for it. Footprint editor, here it is. Okay. Yeah. So let's pick the Module17 library. No, where is it? M17 Smart Mic, yeah, that one. That's the one. New footprint. And okay, oh, so we will need 8 pads. Those will be through hole, I think. Yeah. Circular, and I guess the hole is gonna be 1 millimeter. I think this is gonna be enough. Okay, I think this is good enough. Oh. Okay, and I think we do need like 8 of those, like this. Oh, sorry. Let's reduce those side panels. We also need 2 holes, which, how should I think I can do like this. Can I not? Oh yeah, okay. Non-plated through hole. And we need them to be 3.2 millimeters in diameter. Like this. And then the 2 small ones on the bottom, which are, I think it will be SMD, pad shape rectangular, and it's gonna be 0.5 by 1.8. Okay. And the edge of the board, we are gonna put it in the drawings. And so I guess the board edge is defined by this line on the drawing. And let's move everything so that the line is exactly on the x-axis, yeah. So these are 5 millimeters away from this line. And they are 15.8 millimeters apart, so that means half of this and like this. So those two are placed correctly. Those are minus 7.95 and minus 7.95, and they are 11.3 millimeters apart. Anyway. Yeah, of course. Okay, so that's good. Okay, next are those which are 14.3 millimeters away from the axis, from the edge of the board. Those minus 14.3 minus 2.54, so minus 16.84. Okay, so now okay, I guess so. Those are 8.89 millimeters apart. So I guess this is minus 0.5 times 8.89. This is like this, and then we have to do this minus 2.54, this minus 2.54 times 2, and this minus 2.54 times 3. Okay, it looks like what's on the diagram, so that's great. Hi, Steve. Saw your message a bit late, but hi. Okay, I don't think I have enough holes in this diagram, do I? Do they have any 3D model available? Oh no, okay, but okay. So the two square SMD pads are supposed to be slots actually. I guess, yeah. Okay, so let's modify this. We should give it a bit of clearance around the edges, so let's do like this. pad number is gonna be SH for shield. I just hope that I numbered the pads correctly, and that I'm not sure. They don't say anything about it, I think. Too bad. Okay, well, I think the only thing we need to add is maybe first modify this. So the connector is 16 millimeters, so let's do -9 to +9. Silk screen. How should I do silk screen for? Oh, maybe let's try to have a look at the one KiCad has. Yeah, okay. It looks like what we have. Okay, let's see what kind of oh, they used twice. Okay. So the drawing, it says that the case is 16 millimeters wide. So let's silk screen square, do 16 by 18.5. Yeah, but of course it's gonna be going just right on the holes here, which we don't want, so let's widen it a bit. Like this should be good enough. Okay. And yeah, we need a courtyard too, which is gonna be on the bottom, on top and bottom. Oh yeah, maybe we can just do the margins. So like this. And we are gonna add 0.5 millimeter on each side. And the courtyard is gonna be, I guess, basically the same as the margins. Okay, what's the component? SJ13 5 blah blah. This one. What's it complaining about? Zero sized pad pinned to 1 micrometer. Yeah, it doesn't tell me much. What pad is it complaining about? Can I get the list of the pads? MJ12 blah blah blah. Where is that one? Okay. Okay, it's not complaining anymore. Why not? Anyway, we now have the footprint for the 8P8C connector, so we can go on the PCB, on the schematic first, connectors, and it's this one, footprint. We can just use this one. And the value is gonna be this. And we need the LCSC number, which is right here. Great. We also have MPN like this. Now we can go to here, import, and here is the connector. Okay, we see that. Oh crap, it's not far away from the screen. Much closer than what I anticipated. No, you're right. It doesn't have to be flush with the edge. It can, yeah, it can actually be Can get out a bit. You're right. I think I should like hang it by 1.6 millimeters, maybe about the thickness of a board, so that it goes flush with the or same plane as those. Okay, let me just draw a line 1.6 millimeters away from here. Well, maybe, like, should we align everything on the Kenwood or align everything on this line, which is 1.6 millimeters away from the board? So that means that if when you put it in the enclosure, it should be like just flush with the face of the enclosure. .6 plus the thickness. Thickness of what? So the 1. I think it's gonna be 1.6 is the thickness of the PCB, and in my reasoning, the PCB is against the board. So maybe we can give it a bit of clearance because it's not gonna be like straight on, but I would prefer them not to go further than the face, so maybe 1.6 is good. Yeah, you prefer them to stick out of the face, or like face and then the going a bit further, or you prefer like just flush? Yeah, maybe it's better if we have them sticking out a bit so that we ensure that the connectors are not going to be hindered by the face. Yeah, okay. So we are 1 millimeter. The volume knob is way out, but you are gonna stick a small cap on it, I think. But maybe, yeah, it would be better if it is like this. Okay, yeah, okay, let's align everything on the Kenwood connectors. And draw, I'm just gonna move this line. Yeah, it's gonna be 0.9 millimeters sticking out. I don't think it's that much anyway. And yeah, you're right, Steve. I didn't think about this, but yeah, the nut has to be, the thread has to be getting out for the nuts to be grabbing on it. maybe even a bit more. I guess this would be good. How much is it? It's like 3.7 millimeters. Let's do like 4 millimeters. Okay, I'm just gonna get rid of those old drawings. Okay, so this one, it has to be here to be consistent with the other switches. And so those, I'm gonna move them. Oh no. Can I do like positioning tool, move exactly, move X by, yeah, this. I don't have any of those, so I can't measure the nets. Maybe we can have a look at what is the reference for this one, and it should be in the drawing. So it would be this one, I guess. Hoopla. Reference drawing? Oh, crap. I want to buy your product. Why do you prevent me from downloading the documentation? Oh, and okay, I give up. Sometimes it's just like, yeah. But the net isn't drawn, I think. Oh, bushings. I don't even know what I'm looking at. Oh, nut. Haha, here it is. 2 millimeters. Okay. Cheers. Okay, most important is it's 2 millimeters thick. So, oh, and washer. Oh, is the washer? Yeah, it's here. 2.5. So, do we do like just 2.5 or maybe a? Oh, we have to do 2.5 plus 1.6, so 4.1. Yeah, if they really wanted me to buy, they would supply a CAD. Yeah, I don't know. Some companies, like, they are adamant that you have to register, to give away, basically just give them away your personal data so that they can, of course, spam you with an incredible amount of newsletters in sometimes a foreign language that you don't even understand, I have to say. Just so that you can just download it, see that it's not what you want, throw it away, and never go back to it ever again. Maybe I'm just too young to be understanding all of this, or maybe not, I don't know. Feels like old people deciding, yeah, let's take their email and spam them. It will force them to buy our products. I don't know, I'm trying to make excuses for them, but actually I don't really care. Anyway, it's 2.5 millimeters New World Order. I don't know. Well, if I had to say, to make a guess for the New World Orders, electromechanical components manufacturers would definitely not be in my plans. Anyway, I was saying, so it's 2 millimeters for the washer, 0.5 millimeter for the, 2 millimeters for the nut, 0.5 millimeter for the washer, and 1.6 for the face. So it would be 4.1, yeah. And I said, I think I put 4. Oh yeah, it's kind of 4. Yeah, let's... .1, 4.5, yeah, okay. I'm just gonna add a few comments so that nobody's wondering why there is a random offset between the component and the edge. Okay. Now then, what should we start routing? So this is the power amplifier. Oh, okay, so also, now that I have a few people watching the stream and answering the chats, what do you think about having the OHIS connector and the Kenwood connector being on purpose, being in physical conflict? That meaning that you cannot plug both inside in the on the board, because if you have like the Kenwood connector plugged in this way, the cable is going to be in the way of the OHIS connector, and if you have the OHIS connector, you don't have the room to plug this one. So I think I would do this on purpose so that you can only plug one of those, so that you avoid overloading the outputs and stuff like that. Do you think it would be good to have, or on the contrary, that it's just like stupid design rules? Just tell me what you think. I can just swap them so that we can use both at the same time. Would it be possible to jumper the OHIS? Not sure I understand what you mean. Okay, yeah. Technically, it's feasible, but then we would have to add an additional connector, an additional set of switches, let's say, and I don't think it's gonna be feasible on this revision and on this board. I think it's gonna be quite dense already. And I don't think there is a switch in the 3.5 millimeters connector. It's like, no, I don't think it is. The thing is that you are not supposed to need both because it's the same signals present on both. So it doesn't make any sense to use both at the same time, in my opinion. But yeah, user can be creative and find uses where you didn't find some. We will not ditch the Kenwood, because the OHIS is not in use widely enough yet. So we want to have the Kenwood because you can just plug this and keep using the Module 17 as you always did. While if we ditch the Kenwood, we would have to make an adapter. Yeah, I think I'm just gonna do it like this. So keeping them in this order so that when you plug the Kenwood connector, the OHIS connector is obstructed. Yeah, okay. Physical interference. Okay. Okay, I'm gonna need the schematic on the side so that I know what I'm dealing with. So this is the microphone speaker. Okay. So this is the PTT level shifting. This is the speaker DC block. Let me think. So the microphone input is gonna be very low level. So we might want to avoid dragging this along the board so that it doesn't pick up too much interference from the rest of the system. Yeah, so okay, first predefined sizes, net classes, defaults. Track width, 25.25 is more than we need. I think 0.6.3 is the via size that was used. No, 0.8.4 or no, wait, what? 0.6.3. Let me just have a look at what is standard from JLC PCB. Wait, 0.6.3 is enough. Great. Okay. Wait, what did I do that is preventing me from... Hey, what did I do? I think it's the margin layer that is preventing me from... Yeah, okay, let's remove this. Oh, sorry. Stopped reading the chat for a few seconds and then lots of messages. Hi Bastien. Hi Amo. Will the Kenwood connector conflict with the volume knob? It shouldn't, but well, I'm gonna check. Okay, so that means that I have to update the footprint. And now, yeah, okay, great. Yeah, and we had those 0 ohm resistors, which are put here to prevent the speaker from going, so that you can add a resistor basically, so that you limit the current going through the speaker in the OHIS connector. CNC titanium knob with gold inlay. Yeah, if your volume knob is more expensive than the whole device, maybe you're doing things wrong. Wooden knob, yeah, no, you need a marble knob, which is very stable and heavy, so that it stabilizes the electrons in the board. Because if you shake the electrons, of course it's gonna shake the sound. Of course, everybody knows that. Oh crap, Bastien. So you have to leave university. Oh no. So do you already know what you're gonna do next then? No, I'm not gonna route this on the top layer, but rather on the bottom layer, I think. Oh, great! Knobs from PCB, like full PCB design. That would be very interesting to do. I'm sure there is a way to do it. Yeah, I think everything else than physics is gonna give you less stress, Bastien. And anything else. You're not the first people I know that left this courses. Yeah, people have trouble with it. It's not an easy one. And YouTube, yes, keep watching. Oh yeah, I think after your major you will be able to work on a PhD, definitely. I mean, people from civil engineering at University of Liège barely know how to do it, so. But you have a more practical, lessons, so you will be able to do that. So microphone, speaker, or okay, let's try maybe like this, and not sure actually. No, it was okay. It was good that this way. Yeah, okay. Trying to figure out where to put everything. So there is those two which I have to put together, and then this one which is the microphone amplifier, and I have no idea where I should put each. I think I will try moving this away. I can already start assembling this one, maybe. By the way, Bastien, if you need an internship at some point, just tell me. I might be able to help you find a spot, maybe. So I'm trying to get a feel on how everything here is placed, so that I can place everything around it correctly. Okay, so this is the input. Oh yeah, we also need it. Okay, yeah. As Amos said, we need to make sure that we are not putting the Kenwood connector too close from the volume knob. So let's move them away, maybe. Actually, maybe it would make more sense if we put the volume knob here. The volume knob should be near the amplifier. Move the other jacks over. What do you mean? Sorry guys, when I'm streaming I'm in my own little world inside my head, so sometimes I'm just not keeping track of what you may mean. Oh, okay, great. Well, great then. I have one here, Bastien, which I ordered with the RT3S that I got a few weeks ago. And so just like this, we now have a lot of space to put everything we need. So this is so this is the audio output. Yes, yes, yes. Yeah. Okay. UV390G. What is the G for? Oh, GPS. Oh, okay. 130. It seems quite expensive for something in the flea market like this. UV 390 is not CE? Really? Crap, didn't know about that. Let me check. It does have the logo on it. Well, it's the RT3S, so maybe it's not exactly the same. I don't know. Okay, so those two looks quite good now. So this is the audio signal going to the MCU. Ammo, I'm not sure. No, I'm not gonna swap the. Except if I missed one of your messages, but I'm not gonna swap the 2.5 and the 3.5 millimeters because I want them to be in conflict physically, meaning that you can't plug both at the same time. It's made on purpose. It will be one or the other, not both. Okay, things are starting to look like something. So this is the microphone part, which we can maybe put here. Would it be? I think here would be good enough. Nope, not this. I want to grab this, put it here. So now we even have some room left here. So maybe we should try to get this move them. Oh, it does fit here. No, okay. Gonna try to keep it here. And we have some logic to put, which we can maybe place here for the PTT. And here we will have the silent key filter for the audio. And then we have the amplifier, which maybe we will try to put like this one here and this one here. This, what is this? Oh yeah, this is just actually we can put this here, makes more sense. Okay, so the output, where is it? No, it's this one. I think I'm gonna go from here using a wider track. So maybe let's use 0.5. Then via, which we are gonna enlarge too, I think. Yeah, we are supposed to have like up to, yeah, not 3 watts, but yeah, up to 1 watt going through, which, yeah, it's not that much actually. I think this would be enough. And then we can have it go here up to the DC block capacitor. And then from the DC block capacitor, going out with the same size, you can then go up here I don't know if it's the best design, but I think I'm okay with it. And so I will also enlarge those, even though there is not going to be as much going through. PTT in. Well, no. Let's put those on this side where I have a lot of space available. And I think, no, okay, this way. No, I have to swap them. Like this, enlarge the track. Okay, good. Well, no, let's just because those are susceptible to get modified by the user. So I want to create kind of a thermal break. Like this, so it won't suck as much heat as if it had like a wide track. Okay. Hey Bastien, yeah, I haven't read it yet actually, but I've been told about it. So thank you very much for this article. I've heard that it was very nice. The one you couldn't read. Really? Oh yeah, because of French, I guess. Or because of Dutch, actually. Depends on who you are. Yeah, recognize pigs. Yeah, sometimes you just need pigs to be happy. Okay, let's start putting a few copper planes on the board. Oh, you can download it because, yeah, UBA membership, yeah, I guess. Well, given that you are the author of the article, you are allowed to share the text, I guess. Well, not the translation though, just the text in French. So let's place ground net on the first internal layer. So it already gets rid of most of the rat's nests for the grounds. So that's making it a bit easier to read. All right. I think can I, like, I think I will need to rearrange this. Yeah, I want the IOs to be on the top side of the screen so that we can route the signals from here like this. So those texts need to be aligned this way. You'd space outlets a bit. Yeah, why not? I'm just gonna first finish moving the text, and then we will see if we need to move the text. But yeah, it seems indeed very dense. Yeah, let's try spacing things out a bit. Yeah, this looks nice, in my opinion. What do you think, Wojciech? Good enough or not? Fancy. So I think I'm also gonna try to build a few 3D models for at least for the connectors, so that we can have a better idea of how everything is gonna fit. But I'm not gonna do that while streaming. It's gonna take too much time for this. Okay, microphone. Sound will be better with RGB. True. The updated schematic is not available as a PDF yet. No. You tell me if you want it. If you want me to get it out, I can pause the routing and go back to the schematic. We are gonna have to do lots of modifications on the schematic anyway. Not electrical modifications, but like renumber the components and stuff like that. So maybe I can do it now and get the PDF of the schematic out. So maybe that would be an idea. Either I keep routing or I do that, you tell me. Trying to see how I should orient the MCU. Where does this go? Nowhere. Okay, so we don't use SPI. Okay, so there are two SPIs on the MCU and the OLED SPI. Okay, so yeah, SPI 1 looks like it's not in use. Why is that? Like if, yeah, I think just gonna that needs labels where we have nothing. USB, where are the USB differential pairs? Those I'd like to find. Here. Okay, that's a good spot for them. Okay. Okay. Okay, yeah, this reset button. Reset button. At some point I thought about maybe trying to, maybe we can still do it. Move everything down there on the right by a bit. and have the reset button near the edge of the board so that we can go with a pin and push it if needed. It would require another kind of button, but I think it could be usable. We could make use of that, sorry. The board is, I don't know actually. It's 80 square centimeters. I think it's a tad bit larger than the previous one, but not by much. Fast typing, yeah. Keyboard goes brrr. Oh, I'm no Charlie Whiskey operator. So the button, maybe we could switch it for a button which is facing toward the outside, the edge of the board, so that we can press it with a pin needle. To be determined later on. ferrite bead. Oh, it's the one that makes VDDA and VDDA. Oh, it's connected to the MCU. Oh yeah, okay, of course. So those should, in my opinion, so those are the resistors that go around the PTT. So I think I'm gonna try to place them closer to the PTT itself. Crap, measurements are moving, don't like that. Oh, yeah, hole here. Okay, and this goes to the MCU. Okay. Oh, it also means that the PTT input from OHIS connector is debounced by the debouncing circuit from the Kenwood connector. Well, I think it's gonna be okay. We don't have any PTT button. Okay, what do you mean? Should I tie the PTT net to the reset net? Which would be very funny, but specific. But I don't think there is any PTT button on the board yet. Or did I overlook it? So the PTT, it's just input comes from here. Or from here. Yeah. That's what I, yeah, there is no PTT button on the board because there is no microphone, no speaker, so. Yeah, physical hardware for reset button, yes, but we, oh, sorry, OpenHT PTT, oh, my bad. Yeah, yeah, might be a good idea actually. Do I have a bare OpenHT somewhere? Yeah, here. Yeah, I think we are gonna do that. Yes, and yeah, you're right, I have a 3D model for it, so good point. Yeah, I like this idea. I'm gonna do it, just not now, for the simple reason that I like to get the components from Module 17 in the same library that I made for OpenHT, and I'm gonna do that off stream, and then once I have included this library in the project, I will be able to reuse the switch. But yeah, very good idea, Jay. I'm gonna do that. So for now, let's keep it here. I may have to move this. And move this on the side again, just because I think I'm not gonna have enough room for the button otherwise. Maybe I'm gonna try to get the Kenwood connector a tad bit closer to the OHIS connector too. This should give me plenty of room for what we have planned next. Yeah, okay, if this one fits, I think the OpenHT one will fit too. Okay, just need to redo some connections. I think then we will be able to, so yeah, everything here is ground, so we can, maybe now we can move this down a bit. And then that would give us more space available for the power supply that should come here eventually. DE9, do you think I should recess the DE9 connector a bit too? Or should I like keep everything on the same alignments? I don't think I have a 3D model for the barrel jack. I can't get it too close either because of the this one already has, I think, something sticking out. I might want to move the USB-C and DE9 connectors out a bit. I don't know. Well, this one is already sticking out, so it would be enough. This one, I think, if we make it stick out a bit, it would be easier to plug a cable in. But we have to pay attention that the pads can't be too close from the board, the edge of the board. So that would be the maximum I would go, and keep 0.5 millimeter from the edge of the board. No, I don't think this is gonna be enough actually. Like this, so we have 1 millimeter between the edge of the hole and the edge of the board. And this, then I could align this one, having it stick out like this, and I think it would be on the same alignment. Kind of. And this one, maybe I could put it more toward the inside of the board. So we have, how much do we have sticking out on this side? 2.5. Can we have it like 2.5 from here? Like this. This would indicate 2.5 millimeters out. Let's draw a line here too. Yeah, we have all the silk screen printings. Like, yeah, it's good enough like this. Could even get them closer to the edge, to the pads, sorry. Okay, seems good to me. Well, it's 10 PM already, which means that I'm gonna try to finish with it now. It's getting late. Hey, would you look at that? It fits now. So we will be able to put the power supply here And then we, quote unquote, just have to route everything. Okay, well, okay, I think we are going to leave the board in the current state for now. We did good progress, I think. We found good positions for all the connectors and knobs and buttons. We were able to make space for the future power supply location. And I think we will be able to route everything without too much trouble. It's starting to look like something, even more than yesterday, which I'm quite happy with. So yeah, let's call it a day. Save here, maybe git cracking. Oh yeah, those are the footprints that created some problems with which I still don't know what it was. Looks like it looks like it updated the footprints from previous KiCad format to a new one. Well, I don't know if I need to include those changes. Yeah, maybe. Okay, I think it's good like this. Okay, well, thank you everyone for following along today. I hope you enjoyed. I hope you also like the way the board is looking now, even though it's still a work in progress, of course. I think it's looking better and better. I'm looking forward to see the board once produced, and especially with an enclosure around it. So again, thank you for following along. Don't forget to keep track of M17 activities on the Discord and YouTube channel. Mostly, we also have a matrix bridge to the Discord server for those who want. 73s to all of you, and see you next time. Bye bye.